What is asphalt? Have you ever stopped to think about what makes up the smooth, durable surface we drive on every day? Asphalt is so common in our lives that we rarely notice it, yet without it, modern transportation and infrastructure would look completely different. Behind that seemingly simple black surface lies an ancient history, complex chemistry, and precision engineering. But what exactly is asphalt? Today, we're going to uncover the science and engineering behind one of the most important materials in the modern world. Technically speaking, asphalt is a binding material of organic origin made primarily of bitumen, a black, sticky, highly adhesive substance mixed with mineral aggregates such as sand, crushed stone, or gravel. Bitumen acts like the glue that holds the mixture together and is usually obtained as a byproduct of crude oil refining, although it can also occur naturally in some parts of the world. Chemically, bitumen is a highly complex mixture of hydrocarbons with high molecular weight, mainly composed of carbon and hydrogen, along with sulfur, oxygen, and nitrogen. It does not have a single fixed chemical formula because its composition changes depending on the crude oil source. Its structure includes molecules called asphaltenes, which provide rigidity, and maltenes, which give flexibility and elasticity. It is important to understand that asphalt is not just pure bitumen. Asphalt is actually a composite material formed by combining bitumen with aggregates. The term asphalt generally refers to the final paving material used on roads and highways, but there are several different types. One of the most common is hot mix asphalt, widely used in streets and highways. There is also cold mix asphalt, typically used for temporary repairs and roads with lighter traffic. Polymer-modified asphalt improves durability and resistance, while rubberized asphalt incorporates recycled tire rubber into the mixture. But when was asphalt first discovered? The history of asphalt goes back thousands of years. Archaeological evidence shows that the Sumerians used natural bitumen more than 5,000 years ago to waterproof water reservoirs and temples in Mesopotamia. The ancient Egyptians used bitumen in the mummification process of pharaohs. Even the word asphalt comes from the Greek word asphaltos, used by Herodotus to describe natural deposits found near the Dead Sea. However, asphalt only became widely used for paving in the 19th century. In 1870, Belgian-American chemist Edmond J. de Smet paved one of the first modern asphalt streets in Newark, New Jersey, using bitumen imported from Trinidad. From that point on, asphalt technology rapidly evolved and transformed urban infrastructure around the world. So how is asphalt produced today? The process begins at an oil refinery. During fractional distillation, crude oil is heated in massive industrial towers where it separates into different products such as gasoline, diesel, and kerosene. The heavy residue left behind, known as vacuum residue, undergoes additional refining processes such as vacuum distillation or propane desalting to extract pure bitumen. This bitumen is then heated to temperatures between 150 and 180 degrees Celsius and mixed with previously dried and heated mineral aggregates in asphalt plants. Typically, the mixture contains around 5% bitumen and 95% aggregates. In other words, the bitumen works like cement or glue, while the aggregates make up most of the asphalt's volume and structural strength. After homogenization, the hot mixture is transported at temperatures between 140 and 160 degrees Celsius to the paving site, where it is spread and compacted using heavy rollers to create a smooth and uniform surface. What makes this even more fascinating is that asphalt originates from the same source as gasoline and diesel, petroleum. The black roads covering cities and highways around the globe are actually one of the most valuable byproducts of the petroleum industry. But where is asphalt used besides roads? While road paving is its most famous application, accounting for nearly 90% of paved roads worldwide, asphalt has many other uses. In construction, asphalt membranes are essential for waterproofing roofs, tunnels, and foundations. Airports use high-performance asphalt capable of supporting the enormous weight of aircraft without deforming. Industrial facilities use bituminous coatings for corrosion protection on pipelines and storage tanks. Even dams and landfills use asphalt-based sealing layers to prevent leaks and contamination. So, why does asphalt remain so important today? Its unique properties explain its dominance. Asphalt provides excellent traction, reduces noise compared to concrete surfaces, and offers flexibility that allows it to absorb impacts and temperature changes without cracking easily. Another major advantage is sustainability. Asphalt is considered one of the most recycled construction materials in the world. In the United States alone, more than 99% of removed asphalt pavement is reused in new asphalt mixtures. Modern innovations are making asphalt even more efficient and environmentally friendly. Warm mix asphalt technologies allow production at temperatures 20 to 40 degrees Celsius lower than conventional asphalt, reducing CO2 emissions and energy consumption. Additives such as recycled tire rubber and advanced polymers significantly increase durability and performance. Researchers are also exploring sustainable alternatives like bio-based binders derived from biomass and microalgae. Still, challenges remain. Because asphalt depends heavily on petroleum, its cost is sensitive to fluctuations in oil prices. Roads in extreme climates also require specially engineered formulations. In cold regions, elastomer-modified bitumen helps prevent cracking caused by freezing temperatures, while hotter climates demand materials resistant to deformation under intense heat. Asphalt is far more than just a black layer covering roads. It is the result of thousands of years of technological evolution, combining chemistry, geology, and civil engineering into one incredibly versatile material. From ancient waterproofing techniques to modern high-speed highways, asphalt has played a central role in connecting people, cities, and economies.